Okay, guys, so this is going to be part one of electrochemical cells. The title is Metals Can Be Shocking. But anyway, so come zoom in on this right here. What we're going to do is we're going to take 6 samples of metals. They are, and I'll switch this around so you can kind of see, they are going to be magnesium, copper, silver, zinc, iron, and lead. And what I've got is a well plate here that I'm going to put solutions of each of these metals, and then I'm going to place the metals in their metal ions with a salt bridge from cell to cell, and we can calculate the cell potential, or at least measure the cell potential using a voltmeter. So let's get started. So I'm going to move this around and kind of put this together while you watch. So that's our setup. This is a piece of zinc here. Got my metals all set up. And then I've got solutions of each one. So I'm going to go ahead and make my solution cells real quickly. I've got lead going in back here. I've already set up, because I had to check and make sure this would work, the zinc and the copper cells full. So I'll go ahead and put the iron here in this cell. The silver nitrate and the magnesium nitrate. So that's my silver nitrate. Just a bit. And my magnesium nitrate in the top corner. Okay. Magnesium nitrate is there. So, I'm going to take a piece of zinc and place it on the electrode, and take a piece of copper, put it on the electrode, and I'm going to take a voltage reading. I need a salt bridge, so I've got to connect one cell to the other. And so in this particular case, I'm going to go from zinc to the copper cell. We're going to do the zinc copper cell first. I say we'll just go clockwise, right? We'll go zinc to copper, then we'll go zinc to iron, zinc to lead, silver, and then at the end we'll do zinc magnesium. We'll use zinc as our base electrode here and do everything off of the zinc. So I have over here some filter paper I cut into little strips that I'm going to use as my salt bridge, and I have some very low concentration of KNO3 as my electrolyte. So my salt bridge is full of potassium nitrate, and then I'm just going to put my little salt bridge in there. Dawson, you got this? Mm-hmm. Okay, and so there's a little bridge going from my copper to my zinc, or between copper and zinc. I'm going to place my copper electrode in the copper, doesn't matter the order, and I'm going to place my zinc electrode in the zinc solution, and we have created a cell, and there is our voltage. So you should write down 0.86 volts, a positive cell potential in this case. Okay. So I'm going to take that off. I'm going to use my zinc electrode every time, but I'm going to take my salt bridge and get rid of it. And I'm going to make a new salt bridge for our next one. So going clockwise, we'll now do iron. So I'm going to take my copper lead off here and put on my iron. And then I'm going to make another salt bridge and connect my salt bridge. Wouldn't have mattered what I used as my electrolyte for the salt bridge, provided it didn't have any of the ions I'm already testing for, so that's fine. But anyway, let's go ahead and get this. Oh man, Tull's having salt bridge issues. Okay, so I'm going to take my zinc electrode in the zinc solution again, and I'm going to take my iron electrode and place in that solution, and we once again get, make that so you can see, positive cell potential. So you're writing down 0.42 for your zinc iron cell. Take that out. And we're going to change from our iron cell. We'll go ahead and do lead next. Get rid of this salt bridge. Yeah, you don't want to reuse your salt bridges. That's not good. You'll be mixing ions in both of them. We're not going to do that. So we'll go from here to here. All right. So I'm going to take my zinc here and my lead here, and I get a positive cell potential of 0.36 volts. Okay, pull my salt bridge, new salt bridge, just 2 more to go. This one will be for silver. Gotta make sure you wet the whole salt bridge. You don't want some dry part in the middle. It's not going to conduct anything. Okay, let's get that knocked down in there. So that's my zinc cell. The other one is going to be silver, really pretty. Put my silver in there. So there we go, 1.23. That's kind of low. Oh, that's high. Sorry, I was like, that's really low. Now it should be high. So we got 1, let's call it 1.23 volts for our silver, our zinc silver cell. All right, so I'm gonna take that silver, use the silver. And the last one will be our magnesium cell, losing the salt bridge. We'll come back here. Solution, let's go. Let's go. Okay. And I've got my magnesium and zinc. So here we go. Pay attention. This one looks like it's negative. Is point. Let's see if I can get this to stabilize. We'll call it 0.78 volts. Oh, it's going up a little bit. I disagree. We'll call it negative 0.81 volts. We'll call it negative 0.81. And that concludes that part of part one. What was the name of part one? Metals can be shocking. So you are asked to do a couple of things with this data. You are asked to order them according to cell potential for each one of the metals. So that's it. I'll see you guys in part two.